To talk to you guys about the Projectile Motion Lab. So again, I'm going to show you guys how to get there. So the first thing I'm going to do is I'm going to go to the course materials and hit content. And then when I do that, I'm going to go to the two-dimensional kinematics unit. And I'm going to just go to the first page. It may take a second to load. Okay. And then I'm going to go, the picture should be in the sidebar, or the lab, sorry. So I'm going to wait till I get to see the sidebar right here. So this is the Vector Edition Lab, which I already walked you guys through. So I keep going till I get to projectiles. Okay, Projectile Motion Virtual Lab. So I'm going to click on that, and it's going to download. Okay, and then I'm going to pull this screen down because I don't need that right now anymore. And I'm going to put my lab right here. Now I'm going to click here. And I'm going to have to hit download. I'm going to close that because I don't need that anymore. When it downloads, I'm just going to try and open the file. It's going to say that it can't open it because it's from an unidentified developer, and that's okay. I'm going to go to my security. I'm going to tell them that I want to open it anyway. And then it should pop up. Okay, so here's my projectile lab. I'm going to move it so I can see the lab and the lab paper at the same time. Okay. So I'm going to just read through this lab and see what it says it wants me to do. So it says click on the arrow in the middle of the image to run the program. Okay, so fine. I'm going to hit fire. Okay. Oh, okay, that's saying to download it. Now that I've already downloaded it, I'm good. Okay. So we need to copy the default settings for angle, initial speed, and mass, and write all that down. Okay, so that's the stuff that is over here. Okay, so 80 is my angle, and my initial speed is 18. My mass is 2, and my diameter is 0.1. Okay, and then it says, I'm going to look at the top of the screen. Okay, that's right here. And see which variables are calculated by the program. Okay, so that's the range, and that's in meters, the height in meters, and the time in seconds. I'm outside, so if you hear a guy mowing his lawn, that's our next door neighbor. What variables can be changed by the user? We can choose the item, right? We can choose the angle, the initial speed, the mass, and the diameter. And we can also choose if we want air resistance or not. Right, that's down here. We can check air resistance if we want it. Okay? And what are the different things that we can fire from the cannon? Okay, so we can fire a tank shell, whatever that is, a golf ball, a baseball, a bowling ball, a football. Yes, they're all balls. There we go, pumpkin, an adult human, a piano, and a Buick. Okay. Then it says launch the cannon at a speed of 10 meters per second, right here, at an angle of 35 degrees. Okay, so I'm going to change this angle to 35. I'm going to change this initial speed to 10. I'm going to change my mass from 2 to 6. Well, I'm going to leave it at 2. Okay, so we're going to, looks like we leave it at 2. And then we go to 6, and then we go to 8. Okay, and we're going to record the range each time. Okay, so here we go. I'm going to hit fire. Did I choose what I was launching? I guess a tank shell is a cannonball. So let's try that again just to make sure I did it right. Erase. We'll just leave it like that. So 35, 10. Okay, so it says my range is 11.1. Do you see that there? So I'm going to put that here. Okay, and then I'm going to change I'm going to leave everything the same, but I'm going to change my mass to 6 and see what happens. My range is still 11.1. Okay, I'm going to change it to 8. See what happens. Still 11.1. And what that's telling me is that the mass is not affected, doesn't affect a projectile because we're not doing air resistance. And, you know, if you look at our formulas, it's not going to show it anyway. So now we want to try the angle of launch that gives the greatest range. Okay, so I'm going to try every 5 degrees. So I'm going to do 5 degrees, fire. That gives me a 5.9. Okay, let me do 10. It's going to give me 6.9. I'll do 15. It's 8. And at some point we'll see, like, we'll get to where it's going up and then, like, how it's going up now. And then it's going to go back down. And so we'll know that it's, that was the max. So 20 degrees was 9. Let's do 25. I'm leaving them all here so I can see how they're getting bigger. But you can erase it between each one. That's fine. Okay, 10.6. Okay. .3 for 40 degrees. Getting 11.3 for 45. Let's see what we get for 50. Okay. Okay, so the greatest range is going to be between 40 and 45 degrees. Do you see how it's getting bigger, then now it's going down again? Okay, so now I'm going to erase that, and I'm going to launch an object at 15 meters per second at 65 degrees. I'll put 65 here, 15. Doesn't really matter what object we use. I'm just going to keep my 8 kilograms just to do it. And then I'm going to record my height upon landing. Okay. Okay, so our height is equal to negative 1.2 meters. And if it's negative, we have to explain that. Well, you see how right here, we're starting here, but it's ending underneath here, where the target is actually underneath where we started. So that's why it's negative 1.2. Okay, so it hit the ground lower than where it started. That's why you're getting that negative height. Okay. Now we're going to use this tape measure to measure the height at the highest point, and I'm going to put that here. So I'm going to kind of, let's see. Okay, so I get 9.4 meters. You see that down here? Okay. Now, what equation can we use to calculate the horizontal displacement of a non-horizontally launched projectile? So for horizontal displacement, we always use the same formula. And it's always going to be our Vx is equal to d over t. And the d is the thing we're going to solve for. Okay. On the PhET program, what is the horizontal displacement? So the horizontal displacement is our range. Okay. So I'm going to write that here. I'm going to write range is equal to horizontal displacement. Okay. Now, what equation can we use to calculate the vertical displacement of a non-horizontally launched projectile? So, what I'm going to do is I'm going to go, I'm actually going to go back to our class website, and I'm going to see, it should be on the formula sheet. If it's not, it's definitely in the video. Okay. So I'm going to go to this projectiles and motion graphs video right here. And I'm just going to go through until, now you guys should have the formulas written down somewhere, but I don't really. Let me see, here we go. So once this pulls up, once it loads and pulls up, that's, these are the formulas. And they're really the same as the angle projectile formulas. Okay, so if we want to calculate the vertical displacement, we need to use one of these formulas that has an h in it. Okay, so we can use VFY squared. Sorry, this should be VFY equals VIY squared plus 2GH, or we can use the HF. Uh-oh. I think it thought that I was, there we go. We can do HF equals HI plus VIY plus 1/2 GT squared. Okay, and let me put all these squareds in here so we don't get confused. And I'll put all my superscripts in, or my subscripts, excuse me, in here so we don't get confused. Okay. So we can use either one of these. It just depends on which variables we have. Okay. So now it wants us to drag the cannon to a height of 10 meters. Okay, now the only way I'm going to figure that out is if I'm going to put, okay, I'm going to use my tape measure, and I'm going to measure it to 10 meters, and then I'm going to put the cannon to 10 meters. So I've got the cannon X or plus sign is on that one, so I know it's 10 meters. Okay, so that's my height of 10 meters that they asked for. And then I'm going to set the angle to 0. And then I'm going to choose a launch speed and an object. So you can use whatever you want. Okay, so I'm going to choose a golf ball, and I'm going to choose an initial speed of 10. Okay, you can do whatever you want. And I'm going to erase what I already had. Okay. So I'm going to hit fire. Okay, so here's what I've got. And it says to sketch it, but you can also just put in a screenshot. So that's what I'm going to do, just because it's easier. And it's sometimes, I don't know if you guys know, it's kind of hard to sketch things on the computer. So there we go. And it actually has my range there, but I'm going to write range underneath just to be safe. I want to make sure my teacher knows that I followed all the steps so I get full points. It makes, the easier it is for my teacher to grade it, the easier it is for me to get my points, right? And then it says you can't use the parallelogram method to determine the components of the initial velocity vector. So what two equations do you use to determine the x and y components of a projectile? Okay, so this is a horizontally launched projectile. Okay, so the first thing we'll do is find time. And then once we've found time, because we know our initial speed, and we know our range, and we know our height. And we know the time. Oh, they already told us the time. Excellent. That makes it even easier. Okay. So if we want the x component, right, the Vx, we can just use d over t. And our range is d, right? And our time, so we can just do 14 meters over 1.4 seconds. And that'll give us our Vx. Just 10. And then to do the Vy, we can use any of those other formulas. So let's see. And honestly, our Vx, I should have already known this. Because we launched it horizontally, duh, our initial speed is 10, and that's our horizontal vector, right? And then our vertical speed is nothing, right? So Vy, or our initial y velocity, is just 0. And we don't have to use an equation for that because we just know that because it was a horizontally launched projectile. Okay, but if we wanted to, we could, use one of those kinematic formulas like these. Okay, so now we want to drag the cannon back down to ground level. Okay, so it's on the ground. And I'm going to set an angle for launch. Choose an angle of 50 degrees. Okay, I'm going to keep my golf ball, all that sort of stuff. And it says sketch your space, but I'm going to go to part B, and I'm going to go ahead and put everything in there before I take my screenshot. It says launch it at an initial speed of 18. So I'm going to go ahead and put my 18 in here. Okay, and then I'm going to fire. Woo! Let's see where it went. Let's see if I can open this up and it'll tell me. There we go. Okay. So I'm going to take a screenshot. And I'm going to put this, I'm going to put it back. I'm going to put this screenshot in for my sketch. Okay. Now I need to determine the vertical and horizontal components of the projectile's velocity. So if we go back to this video, okay, the horizontal component is this this, if you see in a second, I'm going to cross it out, but the horizontal component should be AX. So these two letters are swapped. So you should have AX equals A sine. Okay, so that's how I'm going to find my horizontal component, and then I'm going to find my vertical component by doing a cosine theta. Put these in red. I'm not going to solve these for you. You guys should know how to do this. Your A is equal to that 18 meters per second, and your theta is equal to, what do we have our angle? 50 degrees. But other than that, you guys should be able to solve that. Okay. Now I'm going to go back to my program, and it says record the range. So the range was 33.5 meters. Okay, and now it says calculate the expected range of the projectile if your initial height was 1.8 meters. Now this is throwing people off a lot of places. Since we're doing the range and it's the horizontal distance, right, we just do Vx equals d over t. So even with that initial height of 1.8 meters, you don't need that, okay, because you're just going to do your range of 33.5 divided by your time, which is 2.9, okay? $11.55. Okay, so that's all you do. You don't even use the height in the formula. Okay, now I'm going to move this up just so I can find it. Now we're going to drag the cannon to a height of 13 meters. Okay, so I'm going to use this to do 13. Let's see if I can. Okay, 12.99 is going to be as good as I'm going to get. Okay, so I'm going to move my cannon up to 12.99. And then we want an initial speed of 10. And I want an angle of 0. Okay. So, okay, so this is the same kind of question as question 15. Okay, your horizontal is just going to be whatever you started with, and your vertical is going to be 0. Because you're launching it horizontal, so it has no y component, initial y component. Okay, so it says show your equations. You can do this for this one if you want. And then calculate the time your projectile is in the air. Okay, so I would use, let me see if I can go back to that video. Let's see what we know. Let me write what I know. I know Vx is equal to 10. VIY is equal to 0. Let's see, we know the range, right? 16.1. Although that's not really going to be helpful. Well, it might be. Okay. So for this one, there are two things you can do to do time. You can use your Vx equals d over t. and solve for t. Or you can use, if you want time, you can use your HF equals HI plus, I think I already typed this one. Yeah, so I'm just going to copy and paste it. Or you can use that formula and solve for t. And your initial height is, what do you say this? 13. Okay, now to calculate the range, you can just do Vx equals d over t. And then I'm not going to solve this for you. You guys can do this math. And then it says move the target to match your range. Did you hit the target? Well, we already hit the target, so yes. And then you're going to write a conclusion about your lab, what you proved. Again, I don't like prove, it's what you learn. Okay, so I didn't solve the math problems for you. I feel like you guys can do that yourself, but I did at least give you some formulas that you can use to solve those. So that's how we do the projectile motion lab.